All right, so here to help with solving equations that involve expressions that are not simplified. So if you look at the expression or the equation that I have here, you can see that I have 4 multiplied by everything inside the parentheses, the 2x minus 3 is equal to 28. So this is not simplified. We have to use the assured property on the left side of our equation to simplify that expression so that then we can actually take the steps to solve for x. You always want to make sure are both sides of my equation simplified. The right side here, 28, nothing we can do to simplify that. So there are multiple ways you could go about solving this with the assured property. You may see other ways if you're watching other videos where you can divide both sides by 4. Because again, remember, everything that we do to one side of the equation, we must do the other. So you could start by dividing both sides by 4 to get rid of this 4 that we're multiplying by. But to really stick to what we've been talking about in class, so because some have struggled with this rule, is to make sure that you simplify before you solve. So if I simplify before I solve, and I'm looking to multiply everything inside the parentheses by 4. So you can use the kind of my lines here, or I've had a lot of students using the area model to make sure that we can solve with the assured property and saying, okay, 4 multiplied by 2x and 4 multiplied by negative 3. So 4 multiplied by 2x is 8x. 4 multiplied by negative 3 is going to be negative 12. And then that is what's inside my areas of my rectangles here. That was my new expression. So 4 multiplied by in parentheses 2x minus 3 simplifies to the equivalent expression, 8x minus 12 is equal to 28. So now I can see, all right, there is no more assured property that needs to be simplified. There are no like terms because I have 8x with the variable x, and I have minus 12 which is a constant. So now I'm into the normal steps of solving a two-step equation. So again, first I want to undo addition and subtraction because we're using the order of operations in reverse order. So I undo or do the opposite. Again, this is called inverse operations. Okay, the opposite of subtracting 12 would be to add 12. Whatever I do to one side, I must do to the other side. So when I add 12, it gets that subtraction of 12 off the left side because the end goal is really to isolate our variable x and get it all by itself. So I get 8x is equal to 28 plus 12 is going to be 40. So then I have 8 multiplied by x is equal to 40. I can then divide both sides by 8 because that is the opposite of multiplying by 8. And x is equal to 5. So I can check my solution then also by saying 4 multiplied by 2 multiplied by my solution, my value of x, 5, minus 3 is equal to 28. So here, since I'm not solving for x, I'm not doing things in reverse order, I can use the order of operations like normal. So I'm going to solve or evaluate what's inside parentheses first. So 2 multiplied by 5 is going to be 10. 10 minus 3 is then 7. So then 2 times 5 is 10. 10 minus 3 is 7. So then I'm checking, okay, is 4 multiplied by 7 equal to 28? It is. So I get 28 on both the left and the right side of my equal sign, which means that I am correct. So that's solving an equation that involves the distributive property. If you were to see a problem that looked like this, and has a fraction there, the process is no different than what we had just talked about. So you're going to, again, simplify. Right? So doing this one a little bit quicker, 2/5 multiplied by everything inside would be 2/5 n, because this is 1 n, so 2/5 multiplied by 1 is going to be 2/5, but again, we're multiplying it by n as well, so we have to have the n there. 2/5 multiplied by negative 15, and you could do 2 times 15, which is 30, and then divide it by 5, which is going to be 6, but this is negative 15, so 2/5 multiplied by negative 15 is negative 6, is equal to 14. So now I want to solve. First step to undo addition and subtraction. So I undo subtraction of 6 by adding 6 to both sides. I get then all that's left on the left side would be 2/5 n is equal to 14 plus 6 is 20. So now I want to undo the multiplication of 2/5. So we've had a couple different ways. So we know that the opposite of multiplying is to divide. So we could show dividing by 2/5 here. And many students have done that, but remember, the more correct mathematical way of doing the inverse operation here is that when I'm dividing by a fraction, remember, With fractions, we use keep, change, flip to divide by fractions. So what that means is I'm keeping both the left and right side the same, but I'm changing it from division to multiplication, using the dot as multiplication, and then I am flipping or multiplying by the reciprocal. So 2 over 5 is flipped to 5 over 2, and what happens is this cross simplifies, and I end up with just n, but on the other side, 5 multiplied by 2, and I find that n is equal to 5 times 20 multiplied by 5 is 100. 100 divided by 2 is going to be 50 as our solution. So that is another problem in which it has a fraction coefficient. All right, so again, you could check this by saying, okay, I put 50 in for n, so 50 subtract 15, that's 35. 35 multiplied by 2 over 5, and you get 14 as your answer if you're just checking that on a calculator. Last one that I have here is if you have combined like terms. So there might be some equations that you have both the assured property and combined like terms that will be seen later on, but this one just has like terms. There is no assured property. So again, identifying the terms that go with one another, the like terms. So I have two terms that have an x, and then I also have my two constants. So now when I'm actually simplifying this, okay, combining the like terms, negative 4x plus 7, the term that is to the left of, or sorry, the sign that is to the left of or in front of each term is extremely important to pay attention to in whether you're combining like terms or assured property. So this is negative 4x plus 7x, which is going to be positive 3x, negative 9, okay, because there's a sign right there, plus 3. So negative 9 plus 3 is negative 6. So I'm going to write down subtraction of 6, which is the same value as negative 6, is equal to 12. So I want to now start solving, and I'm adding 6 on both sides. We have 3x is equal to 18. Right? I want to isolate my variable and solve for x. So I do the opposite of multiply by 3, which is divide by 3, and x is equal to 6. Just like any of the other problems, you can check this. Okay? You're just putting 6 in for anywhere you see x. So this would be negative 4 multiplied by 6 minus 9. This kind of looks like multiplied minus 9 plus 7 multiplied by negative 6 plus 3 is equal to 12. So if I look at this, this is negative 24 minus 9. Positive 7 multiplied by negative 6 is going to be negative 42. So I could say plus negative 42 or subtract 42 plus 3 and I realize I made a mistake here. This shouldn't be negative 6. This is positive 6 because my answer is x is equal to positive 6, not negative 6. So this should be positive multiplied by positive is 42. So equal to 12. So sorry about that in checking. So important to make sure you get practice with checking too. Just an example. So if I do negative 24 negative 24, subtract 9, add 42, and add 3, I get a value of 12 on the left side, as well as a value of 12 on the right side. So I know that it does check out. A 6 is the positive 6, that is the correct value of x. All right, so hope that helps. Always remember you can check your solutions, and remember the rule: simplify before you solve.